Hey guys, it's Miss Johnson and I'm here to bring you our last notes video for Unit 6. Today we're talking about the binomial formula. So we've been using the binomial probabilities chart, which has the common probabilities for any size n up to 15. Now, you're probably wondering, or maybe the thought has crossed your mind, what do we do if it's not in the chart? How do we find the probability if our n and our x or our p-value is not in the chart? Well, we have a binomial formula, and this binomial formula is what was used to actually create every probability that is in that common chart. So you could use this binomial formula every single time you do a binomial distribution probability. Now, the chart of common probabilities helps us. It saves us a little bit of time, but this formula works every time, and it's how all of the probabilities in the chart were created. So let's write down that formula for a second. Your probability formula looks like this. Probability is equal to, there's three pieces. We have the combination of n choosing x items, which we'll revisit that combination, times the probability of 1 raised to the x power, times the probability of failure raised to the n minus x power. Okay, so what we're looking at here is these probabilities, these pieces are the number, this first one right here, this is the number of ways to choose your successes. Okay, so there's a lot of different ways that you can pick, say, 5 things from a group of 15. Okay, this middle piece is the probability of success. But we can't just consider the probability of success here, and it's raised to the number of successes. That's what's happening. So it's kind of like taking all those successes and multiplying them together. Think back to the beginning of Unit 3 when we talked about the multiplication probability. We would take all of our successes and we'd multiply them together. That's what's happening here. It's just that our probability is the same each time, so I can just take it and raise it to the number of times I want to multiply it, which in this case is the number of successes. And then this last piece, because I can't just consider the probabilities, this last piece is the probability of failure raised to the number of failures. It's raised to the number of failures. So that's what those two pieces are. Now, all of our variables are still the same. N is still the number of trials. X is still the number of successes. And P is still the probability of each one. Those are all the same. Those have been the same all unit long. I want to touch on this first piece for a little bit. So this first piece right here, this may look familiar, hopefully it does, but we haven't probably done a whole lot with it. You did work with it in Algebra 1, but you also may have worked with it in Algebra 2 a little bit. So let's just talk about that for a second. So what that NCR is the number of combinations of n objects when you choose r of them at one time. So on this first example, we're just going to practice calculating the combinations. This is just going to be a review for us. So this was our combinations formula, and if you remember back to talking about combinations, this exclamation point meant factorial. Okay, so see if that word rings a bell to you. Factorial. Factorial means that I multiply all the integers from that integer down to 1. So when I do that, let's take a look at example A. So I've got n factorial, that's the number of objects. Then I do n minus r factorial, and I do another r factorial in the denominator. Multiply all those things together. So let's take a look at part A, and I'm just going to write out that formula as if we were going to do it by hand. So 5 factorial on the top. In the bottom, I do 5 minus 2 factorial with another 2 factorial. what that would look like is 5 times 4 times 3 times 2 times 1. That's what that factorial does. 5 minus 2 is the same thing as 3, so 3 factorial looks like 3 times 2 times 1, and then this 2 factorial is another 2 times 1. So then if you remember, we would go through and we'd cross a bunch of this stuff off. So 3 divided by 3 cancels out, 2 divided by 2 cancels out, 1 divided by 1 cancels out. This one over here, I don't need to divide by 1 because it doesn't change anything. I can also get rid of this 2 by taking 4 divided by 2 and calling that a 2. So I end up with just 5 times 2, which is equal to 10. So my NCR there is equal to 10, okay? Now, fortunately for you, we have ways that we can do this on our calculator. So I want you to pick up your calculator. I'm going to kind of write out some keystrokes here, and I'm going to use this 8C3. So if I'm using if you have a TI-84 or a graphing calculator, here's how you would type this into your calculator. You need to put the 8 in first. Then you need to go find this combinations option. So on your calculator, you're going to hit the math key, which is on the very left-hand side. You're going to arrow over to PRB, which stands for probability. Then there should be an option that you see that is NCR. That's the combinations option. You want to hit enter on that to pull it to your home screen. When you hit enter on that, then you put in the R, which is 3. Then you hit enter, and you'll get your answer. Okay? When you do all of that, hopefully you ended up with an answer of 56. Okay, that's what we ended up with there. Now, if you're a person who's using a TI-30, if you have a little scientific calculator, here's what you would enter on your calculator. You actually have a PRB button right on the calculator itself. You still have to put that 8 in first. Then you'd hit the PRB button. Then you would arrow over until you are underneath that NCR option. So you'll see a little line that's underneath your NCR option. Hit enter on that. Sorry, I probably should have put an extra enter up there up above. Hopefully you were able to follow. So hit enter on that, hit your 3, and then hit your enter again. And there you should also have gotten an answer of 56. Hopefully you figured this out, but you actually need to hit enter right here to get it to your home screen. So I'm sorry about that I didn't have that in there the first time. So let's go ahead and type in the 6C4. 6C4 is going to be, so that's where I would do 6, and then I'd hit math, and I'd follow all these different keystrokes all along. When I type in 6C4, I get a result of 15. So I want you to practice that on your calculator. Use either these keystrokes if you have the graphing calculator or these keystrokes if you have a TI-30 and see if you get to that answer there. Do it again for the 12C7. When I type in 12C7, I end up with 792. So what that means there is that there are 792 different ways, different groups of 7 if you have 12 objects. So if I've got 12 people standing in a room and I want to make a group of 7 out of that 12 people, there's 792 different groups of 7 that I could create. Think about that for a second. That is just crazy. It's unfathomable. It's hard for us to wrap our heads around because 12 doesn't seem like that big of a number. 12 is not that many students. So I'm putting them into groups of 7. That's really not that big of a group. But there's 792 different ways to do that. So I have to account for that when I'm doing a binomial probability, because if I have 12 objects and I'm asking about 7 successes, there's 792 different ways that I can get 7 successes out of those 12 objects. So that's why this piece is going to be really important for us. This NCR is going to be really important for us in that binomial formula. All right, so let's just practice the formula a couple of times. So taking a look at example 2, it says find the probability of getting 5 successes out of 8 trials if the probability of successes on each trial is 28%. So here's where I've got an n equaling 8, which is in my table, but I've got a p equaling 0.28, which is not in my table. So anytime you have something that is not in your table, you're going to have to go to this formula, okay? So that's what's happening here. I have a p-value that's not in the table, so I have to use the formula. If you need to write that down, go ahead and write that down. Not in the table. So I'm going to use the formula. All right, so let's plug all our pieces in. My probability looks like this. I'm going to have 8C, 5, 8 options, 5 successes, times the probability of one success raised to the number of successes, also times the probability of one failure, which I should have done that off to the side here. 1 minus 0.28 is equal to 0.72. That's my Q value. So times the probability of one failure raised to the number of failures. 8 minus 5. Okay, so one more time, let's just reiterate those pieces. So this first piece right here is the number of ways I can choose 5 objects from 8. This second piece is the probability of success raised to the number of successes. This third piece, this last piece, is the probability of failure raised to the number of failures. All right, so now let's actually go through and calculate. One thing that you can do for yourself to make your life really easy is just take the 8 minus 5. You know that there's 5 successes, that means there's 3 failures, because that's how it works in binomial. It's either a success or a failure. The next thing is do this piece first. You have to calculate this number first. You can't type anything else into your calculator until you calculate that number first. So I'm going to go ahead and type that into my calculator. I grab my calculator here. I've got an 8 in first. I hit the math key. I'm using a graphing calculator, so I'm going to hit the math key. I'm going to go over to my probability menu. I'm going to look, for me, it's option 3, NCR. And then I put in my 5, and I get 56 there. So 8C5 gives me 56 times 0.28 to the 5th times 0.72 to the 3rd. Now the rest of this, you can type into your calculator all at one time. So there you go. You've got 56 times 0.28 raised to the 5th. Make sure you arrow out of that exponent so that you can type in the next thing, times 0.72 raised to the 3rd. When I type that in, here's what I get. I get 0.0359729 and so on and so forth. Now, we round our probability out to the 3rd decimal place, which means I'm going to use the 9 to round the 5. So my probability is about 0.036. All right, let's try the next one. We're going to look at number 4, example 4 here. Find the probability of getting 5 successes out of 10 trials if the probability of success on each trial is 0.37. All right, so again, my n is equal to 10, my x is equal to 5. Both of those things are in our probability chart of the common ones. However, this probability value of 0.37 is not. Since 0.37 is not in the table, that means I need to use the formula. The other thing that's really good to find from the beginning is your Q value. So Q is going to be 1 minus 0.37, which gives me 0.63. And then I can go ahead and type all those, or write all those out of my formula. So probability is going to equal, I have 10C5 times 0.37 raised to the 5th times 0.63 raised to the 10 minus 5. Okay, I can go ahead and figure that out. If there's 5 successes, that means there's 5 failures for a total of 10. Then I'm also going to type that into my calculator first. So 10 math probability, I hit the wrong thing, 10 math probability, option 3 for NCR, and 5 successes, that's 252. 252 different ways to choose 5 things out of 10 choices. Then I have 0.37 raised to the 5th times 0.63, also raised to the 5th, and now I can type it all in. So 252 times 0.37 raised to the 5th, again, make sure you arrow out of that exponent before you keep typing, times 0.63 raised to the 5th again. I get a probability of 173,425, and it keeps going. I'm going to use the 4th to round the 3rd, and I have 0.173 for probability there. All right, so, oh, and it does say in here, I'm going to skip this piece because I don't think we need to do more practice of this. It does say find the mean and the standard deviation, but we're going to move on from there. You can refer back to the lesson, I think it was 2 or 3, maybe 3, I think it was 3, where we found the mean and standard deviation if you need more practice with that. Okay, let's take a look at number 4, example 4. Find the probability of getting 12 successes out of 16 trials if the probability on each success is 6/7. That's going to be fun. All right, so here we go. So n is equal to 16. Right there, you're off your table. The table only goes up to 15, so you know you have to use the formula already. Your x value is going to equal 12. Your probability is going to equal 6/7. That's your probability of success. Now, if you think fractions, if 6 out of 7 people succeed, that means 1 out of 7 people fail. So my probability of failure is equal to 1 out of 7. So that's going to be helpful for me to know. And that's just by subtraction of fractions. So let's take a look at our formula here. I have the probability equaling 16C12 times, I'm going to put this in parentheses, 6/7 raised to the 12th power times 1/7 raised to the 16 minus 12 power. Okay, parentheses around your fractions is going to be really important in this question, especially when you go to type it into your calculator. So please make sure you use those. I can go ahead and take care of 16 minus 12. If I have 16 people and 12 of them succeed, that means 4 of them fail. All right, here we go. Then the next thing I need is this guy. So let's do 16C12 in our calculators. Enter in your 16. Go find that PRB. For me, it's on my graphing calculator, so I hit the math button, I go over to PRB, and I want option 3. Then I'm going to type in 12. I get 1,820 ways. 1,820 ways to choose a group of 12 out of 16 options. Times that 6/7 raised to the 12th times the 1/7 raised to the 4th. All right, now you can go ahead and type all this into your calculator, but again, please, please, please put parentheses around your fractions. That is going to make a huge difference. So, and then don't forget to arrow out of that power. When you get up here in the 12, you got to arrow down so that you can start the next piece. Open another fraction, 1 out of 7, raised to the 4th. Here's what I get for my probability. Again, please do yourself a favor and type this into your calculator along with me so that you can see that you're getting the same thing I am. I would use the 4th to round to the 3rd, and I get 0.119. 2 tells me to stay where I'm at. All right, one last example. Find the probability of getting 8 successes out of 20 if the probability of success on each trial is 3/4. Oh, and again, we're skipping that mean and standard deviation. Refer back to lesson 3 if you need more help with that. So my n is equal to 20. My x is equal to 8. 8 successes, 20 total. My probability is equal to 3/4. So if you succeed 3/4 of the time, that means you fail 1/4 of the time. That's what's happening there. So I've got my p-value, I've got my q-value. Now let's write it out in the equation. So I've got probability equals 20c8 times, again, use some parentheses for these fractions, 3/4 to the 8th power times 1/4 to the 20 minus 8 power. I can take care of this. 20 minus 8 is 12. If there's 20 total and 8 succeed, that means 12 fail. Then I'm going to take care of this next. So type it into your calculator. 20, math, PRB, option 3, put in your 8. Woo, big number. 125,970 ways. By the way, the more this n increases, the more that increases. That's what's happening there. 20 is a much larger n than we've been looking at, so that's why we have just a sheer more number of options. So 3/4 to the 8th power times 1/4 to the 12th power. All right, let's type it in. So 125,970 times, open a parenthesis, 3 divided by 4, close a parenthesis, hit your exponent key to the 8th power, open a parenthesis, times, open a parenthesis, 1 divided by 4, close your parenthesis, caret key to the 12th power. I hit enter. Okay, this is a really, really low probability here. So you might see something on your calculator like this. You probably see 7.516 ... with an e to the -4, okay? This e to the -4 is the same way as saying times 10 to the -4th power. That's scientific notation. If you remember scientific notation, that means I need to take my decimal point back 4 places because it's a -4. So there's 1, 2, 3 zeros and then the 7. So my probability looks like this: 0.0007516 ... So if I'm technically rounding this to the third, this brings up that point of conversation where we said sometimes our probabilities are so small that they still round to 0. Now in this case, I do have enough to actually round up to 1/1000th. I'd have 001 there if I round that probability. But sometimes there's even some more zeros in here. And then when you round to this one, it's still 0. So that's why in that chart of common binomial probabilities, you see a whole heck of a lot of zeros in there. That doesn't mean they don't happen. That doesn't mean they can't exist. Everything that is in that chart can happen. It's just that the probability of it happening is so low that they round to 0 when you round to the third decimal point right there. All right, so hopefully that helps you get through that binomial formula. If you have questions, let me know. Thanks for tuning in, and this is our last notes video for Unit 6. So you made it to the end. Woohoo! I will catch you next time.